Good day, viewers. My name is Ola, and I welcome you to Imadel Consult this morning. And today we shall be looking at the concept of numbers. Now, why am I taking this concept? I'm taking this concept because number it's a very important aspect in maths. In fact, mathematics is the science of numbers, letters, symbols, and so on. So this is a very important branch of maths. And in any exams you're writing, the first topic as far as mathematics is concerned, it's numbers. For instance, in the Cambridge IGCSE, the first topic is number. In your WAEC, the first topic is number, and that's why they extend it to the number base and the likes. In the Cambridge checkpoint exam, your first topic is number. In your BEC, your first topic is numbers, and any other mathematics curriculum you can think of, the first topic is numbers because they know the importance of this man here, numbers. And aside knowing, they appreciate the concept of numbers. So let's shoot. Now, numbers, as we have demonstrated earlier, that is very important in any branch of mathematics. Numbers can be grouped into two parts. The first part is a real number, and the other one is called the complex numbers. Now, I'm going to be giving you the different categories of these two branches of numbers or two classes of numbers. Now, every number you've come across your entire life, they are classified under real number. You can name it. Is it fractions? Is it decimals? Is it whole numbers and the likes? But you might not have come across this man here, complex number. But I'm going to give you a short um, detail on these complex numbers. For instance, if somebody should ask you to look at the square root of minus 25, if you use your calculator, you're going to get the mass error. So how do we go about that? The square root of minus 25, you agree with me that minus 25 is minus 1 times 25. And if you want to separate this, you have the square root of minus 1 times the square root of 25. The square root of minus 1 still remains times what is the square root of 25, which is what? 5. Now, this square root of minus 1 is called an imaginary root. And that is why your calculator has been programmed for real numbers only. And this is I times 5. So the square root of minus 25 is what? 5i. It's funny, right? So this aspect of math is what is called the complex number. That was what I said in my earlier introduction, that this aspect you might not have come across it, except for those that are in the advanced class. But if also you are interested in this after or at the end of the day or after watching this video, you can drop it in my comment section and I'll do an extensive video rather on complex numbers. We have the De Moivre's theorem, and we have a lot of complex number. We have the modulus, we have the argument, and so on. We even have the end truth, and so on. So it's a principle on its own. And for the fact that this number or the scope of this number limits us to real numbers, so with your permission, I would like to pull this off. All right, so now let me now go back to real numbers. I told you that real numbers are all the numbers you've come across your entire life, right? And they are represented on a real number line. So real numbers are represented here. Every of the real numbers can be represented using this real number line. Some of you have come across this in inequalities, right? Now, real numbers can be rational number or irrational number. Now, under the rational numbers, we have the first part is a fraction. So all fractions are rational numbers. They are rational, right? The next rational number is all integers. I'm going to be explaining this one after the other. The next is the whole number. The next is the counting numbers. Or let me just, when I get to integers, then I will introduce you to the concept of the counting numbers, right? The next is the recurring non-terminating decimals. I will explain each of them. The next thing is the terminating decimals. All these aspects fall under what is called the rational number. Now let's go to irrational. Irrational is just the opposite of rational, right? And we have the non-recurring non-terminating decimals. I'll give you other examples of irrational numbers. For instance, if you want to look at the square root of 2, for instance, you can't have the square root of 2 to give you a perfect whole number. And if you take the square root of 2, you're going to arrive at this man here, non-recurring, non-terminating decimals. That is, it's not repeating in nature and it's not terminating in nature. That means continuous, but the numbers are not repeated. Other examples of irrational numbers, we have root 7, we have pi. Remember, I said it when I introduced you to the concept of recurring and non-terminating decimals. That pi is used as 22/7 for convenience purpose, but the real pi is an irrational number. The exponent is an irrational number. If you take a look at this, just use your calculator and get these values, you realize that they produce non-recurring and non-terminating what? Decimals. And anything square root of a number or square root of a rational number which doesn't give you a whole number is what is called the surd. So root 2 is a surd, root 7 is also a surd. Now let's go to fraction. We all know that fraction is part of a whole. It has a numerator, upper part, and it has a denominator, lower part. So 22/7 is a rational number because it's a fraction. So be it any type of fraction, they are what? Rational number. Then integers. We have the positive integers, for instance, 25. We have the negative integer minus 25, and we have a neutral number 0. So every negative whole or numbers that are whole and positive numbers that are whole, they are called integers. So minus 25, for instance, is a negative integer. 25, for instance, is a positive integer. Please, you should be able to differentiate between both. 0 is called a neutral number, but it is an integer. I hope that is clear. Now, let's now look at the concept of whole numbers. We have a great difference between integers and whole number. This is where the disparity comes in. Whole numbers are 0 and positive integer. So when you combine the numbers 0 and positive integers, then you have whole number. So minus 25 is not a whole number because it's a negative integer. It has a negative sign here. So it's not a whole number, but a negative integer. So if we have minus 257, please disabuse your mind that tells you that this is a whole number. This is not a whole number, but a negative integer. Now, we have recurring non-terminating decimal. I told you that 1/3 in one of our videos is equals to 0.3. That's 0.3333 like that. So it is recurring, repeating in nature, and it is non-terminating. That means it tends to infinity. So they are all rational numbers. Terminating decimal 1/4 is equals to 0.25. You can see it has a final digit. This is a terminating decimal. So all these are rational numbers. Why? All these are irrational numbers. So example of rational numbers: fraction, integers, which you know what they are now, positive, negative integers, and 0, which is a neutral number, is an integer.